CoCalc is, how you might be able to use that for collaborative projects together, and ultimately just advocating for being a whole person in every sense of the meaning, and to really kind of dig into the interests that you have that are outside of science and technology, and utilize those interests that you have to meet people in your local community, and kind of pitch yourself to hopefully get you guys some positions wherever that may be, whether that's in graduate schools, or maybe you're trying to get into industry or something like that. But happy to take questions at the end, and if you have anything else that you'd particularly like to know, I'm a pretty open book. You can ask me anything that you'd like, and hopefully you guys just get something out of this. That's all that I would hope. But yeah, so I'm Blake. I'm the Chief Sales Officer for CoCalc, Collaborative Calculation and Data Science. And essentially what our platform is and what it does, you should be able to see my screen right now. But what this platform does, it enables you to collaborate in real time while using open source programming languages and applications for science. So maybe if I'm not sure what tools that you guys are familiar with, but these are some tools that you'd probably want to get to know if you're looking at the data science, machine learning space, or even various kinds of applied science, whether that be mathematics, physics, chemistry, biochemistry, biology, you name it. Folks are using these kinds of tools to get the analysis that they want, to really kind of showcase their results and bring it to the public. So I'll go ahead and I'm just gonna go ahead and add a upgrade to my project right now. So I'm gonna go ahead and pay as I go. So I'm gonna upgrade my project. And you can see here that it costs me as little as a penny an hour to be using dedicated resources in CoCalc. And what this means, you can actually use our platform for free, but when you're using the free version of the platform, you're using shared resources on our Google Cloud cluster when you're making computations. And the only functional difference is that you don't have outgoing network access, not being that you can't collaborate and that you're not using it online, but that you can't use Git or pip install or pull data sets. But it costs as little as a penny an hour to be able to do that. So here I'm going to go ahead and start with upgrades. I'm going to go ahead and do that now. And then my project is going to restart, and I will be using dedicated resources on CoCalc, and I'm going to have a much snappier computational experience, and also have that outgoing network access that I'm going to use. Okay, so here is CoCalc. I just went ahead and started up my project with these new upgrades, and this banner will now be going away. So this is active. So I can go ahead and press new. So you can see that I have Jupyter notebooks, Linux terminal. Hopefully you guys are familiar with that. LaTeX or Markdown documents for scientific publications. And we also support traditional code servers like Jupyter Classic, Jupyter Lab, VS Code, Pluto for folks that love Julia, X11 graphical desktop for those that are using RStudio, Spider, Vim, Emacs, their own custom IDE. And one thing that I could certainly say that sets us apart in the, at least in the educational technology space, is that we have an integrated course management system that supports automatic grading of Jupyter notebooks via NBGrader. And we're actually the first company ever to come out with a computational whiteboard environment. So I'm sure that I have that pulled up here. So here you can see a whiteboard that I had created. So this is, you can write using a pen and a tablet. I was using my iPad. You can make sticky notes in LaTeX Markdown or rich text for some mathematical notation. And here you can see I can easily switch back and forth between Markdown formatting with LaTeX compatibility. So LaTeX is a programming language that allows you to do typesetting for mathematical equations. And it's pretty much the gold standard for scientific publications. And you can also use this nice WYSIWYG text editor, which is pretty fun. You can bold, italicize, underline, strike through. You can add little links and things like that. You can use images. It's a nice little feature for being able to really kind of format things the way that you'd like if you're not familiar with Markdown or LaTeX. And then here you can see I have that LaTeX equation that I'd created. But this is where things get really kind of interesting, is that this is the first whiteboard where you can actually write using any of your favorite open source programming languages like Python, R, Julia, Octave, C++, JavaScript, Root, Rust, Sage Math, and even custom kernel environments. And one thing that I didn't mention is that, the company that's created CoCalc is Sage Math Incorporated. So that's us. We created Sage Math as an open source alternative to MATLAB, Mathematica, Maple, and Magma in 2004. So one really neat thing about this code editor is that you actually have version control for the kernels themselves. So as you start to use programming languages and using different packages and things like that, sometimes packages will be deprecated. And what that means is that some folks in the community, in the open source community, haven't updated that package for a while, and things can get broken. So you can actually revert back to that previous programming language where the package was working correctly, and you can just run that programming language with the package without having to go deal with any kind of inconsistencies or go check any kind of dependencies in that regard. So that's one interesting thing. I'm going to go ahead and exit out of this and go back over to our little demo file. And what I wanted to do now was just kind of show we support all of the file extensions that you've ever probably heard of. And if something is missing that you use regularly, that's a non-starter for you to be able to use the platform, feel free to let us know. And we'd be absolutely happy to include any other kind of file extensions here from the open source ecosystem. But yeah, so what I really wanted to show now is maybe I'm going to make a Jupyter notebook. So this is what folks are using to be able to do data analysis without just using straight on Linux terminal. So you can choose any of your favorite programming languages. Again, I'm going to use Python. I would say that that's certainly one of the most popular languages out there today. And what's really kind of neat about CoCalc is that it's all real-time collaborative and computational. So you can see each other's cursors moving around. You can see each other typing in real time. So at any time, you actually have this side chat. So I can call my colleagues over. I can say something like, hey, Blaec, check out what I've been up to in my script today. Feel free to leave me some annotated comments and feedback, or contribute directly to the script with me in real time. But the other thing that you could do as well is if you don't have someone to be able to collaborate with, and you can just easily add any of your collaborators via their email address here. But what I can say is that you also have the ability to use OpenAI or Gemini Pro from Google. So maybe I wanted to say something like, I don't know, create me a script. Create me a script that solves the, let's say, the convection diffusion equation using finite differences, which is a numerical approximation technique, and in 2 dimensions. And maybe I want to go ahead and plot the result and give me the LaTeX equation. Okay, so I'm going to go ahead and ask, and now you can see that I'm going to get my little bit of LaTeX here, and it's going to compile for me, and it'll give me my equations. It'll give me what each of the variables components do. It'll tell me a little bit about the PDE itself, and then here it's going to actually give me this script that's going to be plotted. So you could run this code in the side chat, make sure that you're getting the plots or the results that you'd anticipate before you actually port this over in the production level Jupyter Notebook on the left. So that's just some little carrots for being able to kind of get you started with a problem, and then you can modify it for your own purposes, or you can actually iterate on this by replying to the thread, and then it's aware of everything in that thread, so you can kind of continue to have that conversation with OpenAI and work on your code. Now it's finished, and what I'm going to do now is just go ahead and copy and paste it over. So here, and I can go ahead and try and run it as well. I'm going to copy and paste this over. I'll run it over here. And you can see that the kernel's running right now. And what's also a neat feature in CoCalc is once you start this kernel, there's going to be a pool of kernels that are running in the background. So it's not going to take as long the second time when that kernel is actually initiated for you to be able to run that code. So I just wanted to point that out. But here, it's still running right now. And if you ever don't understand what's going on in a particular code cell, you can always hit explain. You can choose your LLM of choice. So GPT 3.5 is free. GPT 3.5 with 16K is for larger documents and things like that that you'd like to train it on. GPT-4 is my go-to for doing anything with actual code or mathematics. And then Gemini Pro is also a really nice version of an LLM from Google. So it also can handle pretty good sized documents. So maybe here I'm just going to go ahead and get a nice explanation for what was going on in that code cell. So it'll tell me what each of the parameters are, what each of the variables do, and kind of give me the underlying architecture of how that problem was solved. And if you ever get an error, like for example, I'm going to go ahead and delete the H out of plot show, and I'm going to rerun this. And of course, it'll give me this error. Next to, hey, help me fix this. And it'll tell me what went wrong with my syntax. It said, hey, you wrote plot sow, not plot show. And you'd want to go ahead and fix that to get the code back up and running again. And it even went ahead and corrected the code for me and gave me another copy. So those are just some nice things that can really help you get started with a nice template to modify for your own purposes. The other thing that I could say here too is that you can video chat with your colleagues. So think Zoom, Slack, Overleaf, Jupyter Lab, GitHub, and a Linux terminal, all within a fully cohesive environment. So maybe here I'll just go ahead and exit out of this chat. And now maybe I want to see what had happened in the document from its initialization up to its current state. And what I mean by that is we have this fantastic time travel functionality inside of CoCalc that enables you to rewatch everything that had been contributed to the document over time. Maybe here I'm just going to go ahead and I'm going to open up this chat again, and I'm going to copy and paste a little bit of this LaTeX just for fun. So let me go ahead and scroll back up here. And I can click on this, and it'll give me the markdown version, which is what I want. And I'm going to go ahead and copy this. And I can go ahead and switch this to Markdown, and I can paste it over. And now you can see when I switch back over to the rich text editor, it gives me exactly what it is that I was looking for there. I'm going to close out of the chat. And what I really wanted to show here was you can see right now I'm at revision 29 out of 39, and you can rewatch everything that had been contributed to the document in fine-grained resolution. Every 2 seconds, everything's recorded. And you can see, you know, everything that's been contributed by whom up to that point. And if something is ever broken, then you can revert back to that previously existing and working piece of code, and then you can build on top of that image. And if you're really lost in the weeds and you need to figure out what went wrong where, you can actually see the change diffs for the source code in JSON format, and you can iterate throughout the document in that sense too. So again, these are just some really nice features that help enable a real-time collaborative Jupyter Notebook interface. And if this feels overly complicated, the really fantastic thing about the platform is that you can actually use Jupyter Classic or Jupyter Lab as well if you're familiar with those. And if you love IDEs like VS Code or Pluto, you can use that as well. So don't feel like that's the only interface that you can use, but it has some really nifty features with integrated AI, and you can make some templates to get started with. The other thing that I could say here is that you have this GUI up top, so you can do your own full-on prompt engineering. It's document aware, so you can have a selection of cells that GPT is aware of when you send, when you actually send the request. And you have these quick fixes like fix errors, autocomplete, explain, review, add comments, and summarize. So these are just some nice little things to get started with. And maybe I am computationally oriented and I really like to use Linux terminal. You can actually split your screen, look at multiple portions of your code all at once. You can use a Linux terminal. So here I'll just go ahead and use ls, and you can see my files inside. The other thing that I could say here too is that you can push, pull, and commit to your favorite repositories using Git. So for those of you that aren't using GitHub currently, I would strongly recommend that you make a GitHub account and that you start trying to apply yourself out in the open source community. There's lots of really fantastic projects to kind of get your feet wet, or so to speak, for being able to contribute some code. And it's important just to start somewhere, do something that's manageable and small for your first thing. And from that, you can kind of build on, you know, more advanced projects, and you can add that to your GitHub portfolio. And then once you're, you know, really kind of looking for opportunities, either in the job market or you're looking to apply for schools, then you can actually use that GitHub that you'd created with these projects and your affiliation there and the contributions that you've made as a really nice bonus for getting into like a computer science department or a mathematics department or another computationally oriented department or job. So I would again strongly recommend that. Also, LinkedIn is a really great application to have to start building a network and keeping up with not only colleagues and peers that you meet throughout your educational experience, but also with professors and folks that might be able to offer you opportunities or connect you with folks that could give you opportunities later. So those are two things that I would strongly recommend just setting up if you haven't already. But yeah, so you can use version control through GitHub, but also use our custom time travel functionality to be able to see what had changed in the document over time. So that was something that I wanted to go ahead and mention there. You can also easily publish your documents. So here you can see it's private. Only collaborators that I explicitly add to my CoCalc project have access. And then you even have the ability, though, to use published and unlisted. So folks that I can send a URL link to will have access to the script. And then you can have it published and listed, indexed via Google, and then it's going to be publicly available on our CoCalc share server. And I will show what that looks like here in a moment. But I am curious, maybe folks can just like raise their hand if they're interested in machine learning or data science at all. Are any folks interested in that these days? Great, yeah, so I see some hands. So what I'm gonna go ahead and show right now is a really cool feature in CoCalc that just came out for the Supercomputing Conference in Denver just about 2 months ago in November. So here, it's called compute servers. So what's really neat about this compute server functionality is you can basically think of Expedia for hotels, but Expedia for GPUs and powerful CPU machines that are more powerful than your local hardware server that you have sitting underneath your desk. So if you want to run a training model, or you would like to do some inference or something like that, you can actually spin up one of these machines. You can also use proprietary languages as opposed to just the things that are in the open source ecosystem that CoCalc provides. So if you're familiar with something like MATLAB, Mathematica, Maple, Magma, Gurobi, Ample for folks that are in the optimization space, those are proprietary languages that require a license to be able to use, but you can actually just, install that software on the compute server and use that license key that you're given to be able to run those programming languages on the compute servers. And you can even use your own on-premises resources. So if you do have that really beefy laptop or server, you can actually connect those resources to your CoCalc instance, all via WebSocket. And you would just go ahead and click on this on-prem version here. And then when you spin this up, you'd copy and paste a line of code into the terminal of your VM that you'd spun up on your local laptop or on your server. But here I'm going to go ahead and use Google Cloud. And what I wanted to show here is maybe I don't even need a GPU, but I just want a powerful CPU machine. You can run these nice little base images for Python, SageMath, R, Julia, and again, SageMath, open source programming language as an alternative to MATLAB, Mathematica, Maple, and Magma for computational symbolic algebra that our CEO and founder, William Stein, had created in 2004. But yeah, so that's again us, but you of course can use Python, and maybe I'd want to go ahead and use a really cheap machine with very minimal resources, all the way up to the most beefy, powerful machine that you'd ever probably want through Google, with almost 12,000 gigs of RAM for $16.89 an hour. So I'm going to go ahead and I'm just going to select maybe a GPU. You can specify the GPU type. Maybe I want an NVIDIA L4, which as a researcher, I think this is a very appealing price. And if you want to run a production level workload, you can actually use like an A100 or something more powerful like an A100 with 80 gigs of RAM. I'm going to go ahead and choose this NVIDIA L4 though. You can choose the number of these that you'd like to run on the machine. PyTorch, TensorFlow, Google Colab, Llama, CUDA, just some nice base images for being able to do machine learning. I'm going to go ahead and use PyTorch. You can choose the machine type that the GPU is going to be running on. Maybe I want a standard 16 with 64 gigs of RAM. And then you see exactly how much that this is going to cost, all based off of the location. So realistically, depending on what you're doing, you may or may not want to reduce latency by making the data center be as geographically close to your location as possible, which is important for large trainings and things like that. Also, maybe it's important for me to have lower carbon emission rates. So, whatever kind of bureaucratic tendencies that your institution has, or, just depending on whatever it is that what values that you have for what kind of, resources that you'd like to be able to use. Maybe you're just trying to get the best deal possible and you want to be able to just use a more powerful machine. You can also have those options, but I'm going to go ahead and choose Iowa. I'm originally from Des Moines, Iowa. So here you can choose between spot and standard instances. Spot instances are great. I want that 65% discount whenever I can get them. But if you're going to run a production level workload and you need to make sure that this machine stays on no matter what, you definitely want to go ahead and choose the standard. You have up to 65 terabytes of disk space to be able to host data. So that is a lot of data that you can be able to do analysis on by increasing this disk space up to almost 65,000 gigs. And then here you can actually use a custom domain name with an SSL certificate. So if you're looking at hosting a computationally oriented website with dash paneling, interactive widgets, you can actually use this custom domain name to be able to host that website all on the compute server. So that is an option. And Yeah, so you once again, you have root access. You can install any kind of software that you want to be able to use on this thing. And maybe I'll just go ahead and I'm not going to actually start this, but when I'm inside of my file, if I want to run this script off of that more powerful machine than what CoCalc provides, I can just go ahead and click on the compute server that I had spun up there. And then I'm running that script on that machine as opposed to on our Kubernetes cluster on Google Cloud. But yeah, so really excited about that. And I think that makes our platform much more viable for being able to do machine learning or data science. And you also don't have to go through the hassles of setting up like a Google Cloud account and go about provisioning resources and asking for quotas and things like that for, you know, more powerful machines, because we've went ahead and already done that. But yeah, so these are just some nice things that you have at your disposal to be able to use. Maybe I want to make a LaTeX document and just show you what that looks like. So I'm just going to use the side chat, use GPT-4 again, and I'm going to go ahead and ask, create me a LaTeX template that talks about why folks in computational science should spend extra time doing extra curricular activities to help get a foot in the door, or so to speak, in industry. And this is what I'm going to be talking about, and I'll give you my personal story after this, but I did want to show you what this LaTeX document looks like, and also why it's good for mental health and stress. Okay, so I'm just going to go ahead and ask for this. Sure enough, it's going to give me this LaTeX template, and it just gives me something to get started with. And while we're waiting for this, I'm going to go ahead and just ask, does anyone have any questions about the platform before I really kind of just dig into some more personal stuff? Is there anything that you guys are particularly curious about that you'd like me to maybe show? I can go ahead and just look in like the chat here if there is anything. And if not, we'll just wait for this for a second and I'll go ahead and I'll just paste this over now. But I'm happy to take a question in the meantime while I'm pasting this, if you guys have anything. Okay, so I'm not seeing any questions in the side chat, so I'm just going to go ahead and keep on going. Okay, so here you can see I've got my nice little LaTeX template, and it gave me, you know, a nice article class document with an introduction and some other things to be able to easily get started with. But yeah, so this is just a little bit about that. I have no idea why that's in a different language, but all of this stuff's commented out anyways. Okay, there we go. So anyway, what I wanted to really kind of get at here was my personal story. This is just, you know, CoCalc, and this is the company that I work for, but I'm going to go ahead and stop sharing my screen now. And I'm going to just tell you a little bit about how I got involved with the company and what I do now, what my actual role is, and also maybe just give you guys some advice for being able to find some folks in your communities that can really kind of help facilitate your learning or give you opportunities to be able to work in industry or some internships and things like that. Okay, so I had met the CEO and founder of CoCalc while I was in graduate school at Oregon State University. We had actually met through our mutual love of the Washington volcanoes. So for those of you who don't know, there are 5 volcanoes in Washington State: Mount Adams, Mount Rainier, Mount St. Helens, Glacier Peak, and then Mount Baker. And I've climbed all of those. And, you know, while I was in graduate school, it was a very stressful time. I had moved all the way across the country from Florida, where I did my undergraduate at the University of West Florida. And I studied mathematics and history there. And I got a full ride out to Oregon State. So I moved out here and left my support system behind. And it was a really stressful time in the middle of the pandemic, always looking for things to do to kind of clear my head and, get away from the school for a little while. So I had the opportunity to meet William actually through a mountaineering forum on Facebook, where I was looking for climbing partners to go climb Mount Adams, and had actually met him very organically that way. He'd clicked on my profile, had seen that I was a graduate student in the mathematics department there, and he was a tenured professor at University of Washington in the mathematics department until 2019, when he decided to leave and grow the company full time. So I had the opportunity to go out with him a few times throughout that the year and a half or so that I had known him before I started working for CoCalc. And he just was the smartest guy that I'd ever met. And when I had finished up my program, I asked him just for some friendly advice on trying to get my CV together, write my resume for opportunities. I was looking at trying to get in with some universities around the greater Seattle area, which is where I live, and also looking into potentially getting in with Pacific Northwest National Laboratory and some other places like that. So I was really just dialing in my hiring materials, and I needed some advice on how I could make those, as keen as possible, and hopefully be able to get some opportunities. So when I did this, I fixed up my CV, I made my personal website, and by the end of all of this, William said, hey, we'd consider hiring you for CoCalc. And my first day, I was actually hired to make solutions for a fluid mechanics textbook by Cambridge University Press. So I'm sitting there inside of the platform for the first time, and I'm writing out these solutions, and I'm using NB Grader, trying to get this automatic grading to work and things like that. And it occurred to me like how amazing this platform would have been while I was actually in graduate school. And I didn't really understand why William had never told me about it. While I'd actually known him that entire time. So my first pitch ever was actually just pitching my role as chief of sales for CoCalc. And yeah, that was essentially how that kind of went. I started working for them and just realistically becoming a science communicator and trying to help break down the siloing that's happening within different fields of computational science, whether that be in academia and different kinds of departments at universities, or also between academia, industry, and government, and then advocate on behalf of using the platform. Because the thing is, we've realized that folks that are going to solve real world problems, they should and will have diverse backgrounds. They're going to use different programming languages and applications from their own workflow, but folks still have to be able to compare results. You still have to be able to write publications together. And ultimately, as an organization or as an institution, we need to be able to focus on the task at hand rather than the arbitrary computing environments. And this is definitely contributing substantially to the siloing. And what I mean by that is you can think of bubbles, right? Where you have highly technical information that not only from the tooling that's being used, but also the terminology that's used in order to address problems that crop up in different kinds of applied science, whether that be mathematics, biology, chemistry, physics, computer science. Everyone kind of has their own flair. And what I mean by that is we all try and solve similar problems at points in time, but we have different, terms for, how we address those problems, the different techniques for how we address them or try and solve them. And by reducing friction in the tooling that we actively use in order to solve these problems, we have more opportunities to start trying to address the differences in terminology and be able to work in more interdisciplinary groups. I'm convinced that real world problems today are going to be solved by super groups of folks where someone has a background in materials science and someone has a background in computational physics and mathematics and chemistry, etc. So, we have to be able to work together in that sense. And when our ecosystem is as fractured as it is today, it makes it really hard to be able to collaborate with folks that have a different niche workflow from your own. And this is something that CoCalc lends itself really well to by enabling folks to collaborate in real time. You can think of basically Google Suites for computational science, where you can see each other's cursors moving around and things like that, leave annotated comments and feedback, have a real conversation about the mathematics and the code that you're trying to implement right next to where you're implementing it. And then you can actually publish these documents like I had just shown inside of CoCalc for folks to be able to view and utilize your research. And one example that I would have of this, and I'll go ahead and reshare my screen, but one example that I'd have for this is the fact that You can actually use the Journal of Fluid Mechanics, as well as graduate texts like Intro to Python for Scientists and Engineers by Cambridge University Press. And here, while you're actively reading through, this is the Journal of Fluid Mechanics, but while you're actively reading through the scientific paper, maybe I see some plots or something like that that feel very relevant to what it is that I'm trying to accomplish in my own research or for a course that I'm doing. You can actually just click on these hot links, and this hot link will take you over to the CoCalc share server. So I'm going to go ahead and share that now. So this is the CoCalc share server. You actually get the Jupyter notebooks and the data sets that belong with the research paper. You can pull it in your account. You can modify it in real time with your collaborators, change some parameters, run the full-scale simulations, and really abstract the value that you want out of the computational journal without having to reinvent the wheel from scratch, rebuild everything from nothing, check the results, make sure that everything is aligning properly, and then modifying it for your own purposes. You skip that first entire headache of trying to recreate someone else's results, because you actually get the scripts and the data sets that go along with that. So maybe here I'll just go ahead and click on the Jupyter notebook, and you can see, you can read through, you can copy this over to your own environment, you can pull it into your CoCalc account, and then you can actually see the full-scale simulations. And we support full 3D volume rendering. So this is a bit more computationally intensive. I'm sure that it'll take a second for it to show up. But I'm going to go ahead and share, and it's a pretty neat little simulation. And what it is, it's actually some vorticity inside of a cuboid with fluid density. So you can see this is some fluid dynamics inside of this cube structure, and you can see that this twirling is would be moving this about. So this is just some really nice examples of some full 3D simulations that are supported for the journal inside of the CoCalc share server. And if I was to click here, you can see again, these are all the different notebooks and things like that that are shared inside of the CoCalc share server. You can see how many folks have viewed them. You can star them to be able to use them later and things like that too. And another thing that I might just want to quickly mention, since I had talked about GitHub earlier, I'll go ahead and switch back over here. So let me know that you can see this. So I'm going to go ahead and click on new. If I wanted to pull a GitHub repository, I'll go ahead and open up GitHub really quickly. So this is GitHub. Maybe I want to take a finite element method repository that I like as an example, and then you can copy and paste the URL. So if you don't know how to use Git, and what I mean by that is using Git commands. So they're commands that you use through the Linux terminal in order to pull these data sets and notes and things like that from these repositories to be able to utilize inside of CoCalc. And what you can do instead is you can just go ahead and copy and paste that. You can just go ahead and copy and paste that into your line right here, and then you can create a download. And then this is actually going to pull this repository inside of my Linux file sharing system, which you can find through the File Explorer over on the left. So that is that. And you can see, maybe here, I'll just go ahead and pop back into here and exit out of that. I'd actually need to go ahead and there we go. So here's the download that I'd created. And you can see I've got my course notes and things like that in the notebooks for being able to actually run some of these things. So maybe here I'd want to go ahead and just use the Spring notebook. And then you can read through, you can see the visualizations, and then you can actively, utilize the information that's here without having to, use Git. So that's that. But anyway, got a little sidetracked there. So what I really wanted to tell you guys is, take the time for yourselves, no matter where you go in life, no matter how technical the program is, take the time to do things that you love and appreciate, because it can actually pay off for you, not only from like a mental health and stress perspective, but also give you opportunities to form relationships inside of your local community, wherever that might be, and get to know folks. And you never know who you'll meet anywhere. Always advocate for yourself. And the other thing that I could say too is try looking for, opportunities at some conferences, and look for opportunities through your professors and ask them, is there any responsibilities that you can have to help with grading, to help with, anything that's along those lines as a research assistant, or, look for those scholarships or, sponsorships that you can get from folks to be able to go to school. And when you decide that maybe you want to go to graduate school or something like that, I always advocate for folks in technical programs to just go for the PhD, because you can get funded and you can always master out later, which is what I ended up doing. I was in a PhD program at Oregon State in a mathematics department. And in the middle of the pandemic, I decided that was no longer the path that I wanted to take. And I had, was able to get my master's degree at no cost to me, aside from, moving out and having those kinds of expenses in Oregon. But I was fully funded by the university itself, and I had opportunities to get to teach to courses of, as not only a graduate student, instructor, a teaching assistant, but also as like a full-on instructor of record for the courses themselves. So I had taught, I think, algebra, college algebra, calculus 1 and calculus 2, as well as pre-calculus several times. But yeah, those were things that had really helped propel me along my path, and just trying to learn how I could take advantage of the opportunities that were given to me, by actively seeking them and trying to go and participate in clubs. Like I was the secretary for the Society of Industrial and Applied Mathematics, which is for my student chapter at Oregon State. And that's one of my favorite organizations. I follow them around pretty profusely these days. And just to maybe give you guys a sense of some of the conferences and things like that you might want to look into, I can just go ahead and share my screen once again with a conference list, and you can see even just like where I'm going to be this year. So I'll go ahead and do that now. Okay, so you should see my screen, and you should also see a list of various conferences and things like that. I had actually just finished up with the Joint Mathematics meeting out in San Francisco, California, which is dually hosted by the American Mathematical Society and was previously hosted as well by the Mathematical Association of America. This is like the largest mathematical conference of the year by far. So it's a great one if that's something that you're interested in. I also participated in the American Astronomical Society's 243rd meeting in New Orleans last week. I just got back yesterday, so that was fantastic. You can, interact with folks in industry, with companies like Lockheed Martin or Northrop Grumman, also with federal institutions and agencies like NASA, the European Space Agency, various kinds of observatories and laboratories that are doing, Earth space science, looking for exoplanets and things like that, or habitable zones. So really interesting community to participate in. Various kinds of statistics conferences. This is the American Geophysical Union. So if you're interested in Earth and space science, this is a really fantastic community to be a part of. They do a really great job of integrating not only academic institutions and federal institutions that are performing this kind of research, but also folks in industry and large tech companies like Google and Amazon participate in this space as well. It can be a really great exhibit hall to be able to go and network and kind of sell yourself and to look for opportunities, and ultimately just learn how to network with folks that are kind of, adjacent to whatever your interests are. I think that their fall meeting, this is the Ocean Sciences meeting, but their fall meeting takes place in December, and I participated a few weeks ago. So I think there was 26,000 people that were there for that conference. So huge community, lots of opportunities there, and I would highly advocate for that. I just so you guys know, that is the primary role that I facilitate at CoCalc, is I advocate and do live software demos of the platform, and I travel all over the place. I did 30 conferences last year, just trying to get to know people in different kinds of computationally oriented communities, see what they're constantly bumping their heads on, how our platform might be able to help in that regard. And ultimately, that's what led to the creation of that compute server functionality with those GPUs and powerful CPU machines that I had shown before. But there are also other really great communities like the American Physical Society. So if you're interested in physics, computational physics, etc., this could be a really great community to look into. But the March meeting is going to be happening in Minneapolis this year. Again, this is another just absolutely massive meeting that takes place. Similarly, you can see this is the Society of Industrial and Applied Mathematics that I had talked about before. So parallel processing for scientific computing. I'm sure that this is going to be a really nice conference, but unfortunately, I'm going to be booked up at the the March meeting for the American Physical Society during that time. But here's an NVIDIA conference. So if you're much more in the tech space and less in the academic realm, I would highly recommend trying to participate in some of the larger tech conferences like the NVIDIA GTC, Google Next, also AWS reInvent, or any of the larger Microsoft events can be really nice to try and look for opportunities. But yeah, so PyCascades is a really cool organization that's focused on Python, and it takes place that the conference is actually going to be taking place here at the University of Washington in Seattle. So that could be a really great opportunity if you're located somewhere around here. The European Geophysical Union. There's just absolutely tons of different events and communities for you to have the opportunity to participate in. AI Stats, ICML, ICML being the International Conference on Machine Learning. These are all just great places for you to be able to go and try and meet folks that are out in industry or that are in academia as researchers or in some of these larger tech companies or even in the publication space. I can't tell you how many amazing folks that I've met from the publication world over this last year. But this is just absolutely chock full of, this list is chock full of places to be able to meet folks that could potentially give you opportunities, help you get into school, help give you internships. And I would realistically say that attending any of the meetings that are listed here would be fantastic. Supercomputing event by the IEEE organization is also, it's one of the largest supercomputing events in the entire world, where folks are showcasing not only supercomputing like from a classical sense, but also for quantum computing and things like that, and software and hardware. So whatever your kind of space is, I guarantee you that there's a community for you. And if you're ever interested, happy to have some side conversations with you guys if you're just would like to explore maybe what some of these communities might look like based off of your own personal experiences or interests. And I'm always happy to be a resource for you in that regard. So I'm happy to just go ahead and put my email in the side chat. So I'll go ahead and do that now. But yeah, I did want to go ahead and leave a few minutes to be able to have some questions if anyone has some. If you guys would like to participate in that sense, I'm happy to kind of dig into some other aspects of, either my experience, maybe some communities that you might be interested in, just maybe some forecasting for like how you might be able to utilize experience at your undergraduate to be able to, how to ask for research opportunities, how to maybe approach professors, how to get into school, like, as far as like an applying purpose or, for graduate school. Happy to answer any kinds of questions that you have if anyone has something. So I went ahead and I put my email in the side chat. Yeah, you're very welcome. I'm always happy to share my story. That's something that I feel very strongly about. I definitely and I enjoy doing that for you guys. So that's not a problem at all. And I'm gonna go ahead and stop sharing my screen now. So. The other thing that I did want to go ahead and just emphasize is, for folks that would like to be able to try out CoCalc, you can definitely let me know, and I'm happy to, give you a free CoCalc credit voucher so you can try purchasing a license or try using GPT-4 inside of the platform, or maybe even use one of the compute servers or something like that. So if you send me an email and you tell me that you're interested in exploring what this might be like, for your own purposes, I'm happy to go ahead and give away some free resources to do that. So I wanted to go ahead and thank you guys for your time. If there's ever